You know what I could really go for? An ice cold Coca-Cola. No!
Well, okay, I guess we can all agree that was something else. But, you know, when someone really wants a Coke, they have to have a Coke. So I did, what I had to do. Anyways, I noticed that all of the Cokes that I just purchased from Costco were a total of 420 ounces for all of the cans. And I was thinking, what if I drank all of those cans in 7 days? I wonder how many ounces that I would have to drink per day in order to do that. So what I noticed was that sounded like division because I'm splitting up those 420 ounces over the course of 7 days. Now, when we're thinking of division, that's really the same thing as repeated subtraction, or in other words, taking 420 and subtracting 7, and then subtracting 7, and then subtracting 7, over and over and over, and seeing how many times that we could go about doing that. Now, in class, we've been talking about estimates that are too high and estimates that are too low. So we're going to look, just like with multiplication, how this could possibly work with division as well. Now, remember that multiplication and division are inverse operations. So when I look at a division problem, I'm trying to think what sort of answer would make sense. So I know that there are 1, 2, 3, 4, 5, 6, 7 groups. 7. And these 7 groups, in this case, represent 7 days. Now, I'm thinking, if I'm looking for an estimate that's too low, I just kind of start thinking about what could potentially happen. So I'm wondering, what if I drink 10 ounces every day for all 7 days? Now, one way to look at this is, well, 10 ounces for 7 days would be 10 times, notice I'm using the dot for multiplication, 7 equals 70 ounces. Now, 70 ounces is significantly less than 420, which tells me then that 10 ounces per day is too low. Now, if I want an even more realistic answer, I could start to try something slightly bigger. So let's do our 7 groups again. 1, 2, 3, 4, 5, 6, 7. I'm thinking, what if I tried something bigger, like, let's say 50? So 15 each. 50, 50, 50, 50. And in this case, we're looking at 50 times 7. Now, one easy way to do 50 times 7 is to just ignore the 0 and do 5 times 7, which is 35, and then add a 0 at the end, which is 350. Now, you'll notice that 350 is again less than 420, so that tells me that the number 50 in each is also too low. But notice that 350 is getting closer to 420, so 50 is too low, but we know that it's close to our answer. So we have an estimate. Now on the other end, when we're thinking of an estimate that is too high, so again, we have 420 divided by 7. I'm again going to make my 7 groups, 1, 2, 3, 4, 5, 6, 7. And again, those 7 groups represent 7 days. Now, what I'm thinking here is, well, I knew that 50 was too low. Let's try something at the next place value. So let's try to put, and I'm going to put it below because it won't fit, 100 in each group. 100 in each of the 7 groups. If I put 100 in each of those 7 groups, that's the same thing as saying 100 times 7, which is 700. Now you notice I don't have 700 ounces total, which tells me that the number 100 is too much. I can't afford to put 100 in each. If I wanted to try something slightly smaller, let's say for instance I wanted to try to put 70 in each. 70, 70, 70, 70, 70, 70. Again, that would be 70 times 7, which is like taking 7 times 7, which gives me 49, and then adding a 0 at the end, so that'd be 490. So I could also say that the number 490 is, we'll see here, bigger than 420, which tells me again that 70 must also be larger than my possible number. Now, just by knowing this, we said too low was 10 or 50, and we said too high was 70 or 100. So just from this estimate, I know that on the low end, my answer has to be between 50, notice we got that from here, and on the high end, 70, or the quick one we did was 100, but we'll say 70. So we're going to say my answer has to be, let's do green here. We're going to say my answer has to be between 50 and 70. Now, here we actually have a really small range. Between 50 and 70 gave me a really good idea of where my answer is going to be, and I don't feel like we had to do that much work at all by using that multiplication. Now, as we go back and do this actual division, I want to remind you, use your place value markers. I'm going to go over here and count by 7s just to help myself out. 7, 14, 21, 28, 35, 42, 49, and we'll stop there. Now, again, when we were over here doing our estimate, we figured out that it was impossible to put 100 in each group because we would have needed 700 total ounces, which we didn't have. So when we go over here to our answer, you notice we're going to put a 0 in the hundreds place because there's only 4 hundreds, and that's not enough to put one in every group. So now we're thinking, well, what about 42 tens? Do we have enough to split that up? So we go over to our multiples. We're going to count 1, 2, 3, 4, 5, 6. We have enough to put exactly 6 tens in each group. And you'll notice it's nice here because 6 tens would fit directly in between 5 tens and 7 tens, or 50 and 70, because we're saying it's going to be 60 something. So we know it's already fitting within our range that we made from the start. So 6 times 7 would be 42 tens. I only had 42 tens, so that leaves me with none. And I have no ones to split up. And if I'm splitting nothing into 7 groups, that's going to give me 0 ones, which tells me that the actual answer to this question was 60, which falls directly in the middle of 50 and 70, which was our range, which was our too low and our too high. Now, going back, I want to remind you of a couple things. Number one, when we're thinking of a division problem, just like with multiplication, I want us to think about what would be an estimate that would be too low, lower than our possible answer, and what would be an estimate that would be too high. One way to think about this, as you'll see multiple times here, is by thinking of multiplication and thinking of what sorts of numbers could we easily multiply by our divisor here, and will it give me something bigger than what I started with or smaller than what I started with. So using this idea of using multiplication to help us estimate a division problem can be really super helpful. So I encourage you to try to use estimation as we get into working on division problems.